Hello everyone and welcome back to the channel. Today we are going to explore the heart of the Arduino UNO, that is its pin configuration. If you have ever wondered what each pin does and how to use them in your projects, this video is exactly for you. If you want to master Arduino projects, then first you need to understand the Arduino UNO pin configuration, and in this video I'll explain every important pin in a simple and beginner friendly way. Let's get started. So this is a Arduino UNO, which is a popular microcontroller board used for electronics, Internet of Things, robotics and embedded system projects. It contains different types of pins used for input, output, power supply and communication. Like it has digital I/O pins, power LED, ICSP header, ATMEL, ATmega 328, then analog I/O pins, power pins, 3.3 voltage regulator, DC power jack. You have resettable fuse, 16 megahertz crystal, USB to serial, IC, USB jack, reset button and transmission and receiver LED. So we'll see these all one by one. Now first let's see the digital pins from 0 to 13, which are numbered from 0 to 13. These are the digital pins. So here we'll get to know their functions also. Arduino UNO, it has 14 digital input output pins which are numbered from 0 to 13, which are used to read digital signals from sensors or send signals, that is the digital signals, to the output devices. And these pins operate only in two states, that is high, which is 5 volt, and low, which is 0 volts. And the pins number, that is the 0 and pin number 1. Pin 0 is the represented by RX and pin 1 is represented by TX. These are the special pins which are used for serial communication, and this RX, it receives the data, and TX, it transmits the data between the Arduino and a computer or any other device. Now this PWM pins are nothing but pulse width modulation pins, that is 3, 5, 6, 9, 10 and 11, which are marked with the symbol this, okay, this one. These marked with the symbols, that is the green color pins, these are the PWM pins, that is the pulse width modulation pins, which generate variable pulse signals to control the LED brightness, motor speed and servo motors. Then you have pin number 13, which is connected to the onboard LED and making it useful for testing and debugging the programs without requiring an external LED. And here you can see the legend, which categorizes the regular digital pins, PWM pins, serial communication pins and the onboard LED pin, and it provides a quick reference for the beginners, that is this blue one. Okay, this blue pins, that is 2, 4, 7, 8, 12. These are the regular digital pins. Then this green pins are the PWM pins, and here orange color, that is 0, 1, 13. These are the serial communication, 0 and 1, that is the orange color. These are the serial communication pins, and red one, it is a special function which is the onboard LED. Then next is the analog pins, that is the pins from A0 to A5. Here you can see, okay, this is marked with the green box here. These are the analog pins of the Arduino UNO, and it highlights how they are used to read real world analog signals. Unlike the digital pins, which can detect only two states, that is high or low, analog pins can measure continuously the varying voltages, okay, between 0 and 5 volt, that is between 0 and 5 volt here, and these varying voltages are converted into digital values by the Arduino's 10-bit analog to digital converter, that is ADC, and this ADC converts the input voltage into a numerical value ranging from what? Ranging from 0 to 1023, allowing the microcontroller to process analog data accurately. Now here you can also see, here you can see the pins from A0 to A5 on the UNO board. So here typical applications include temperature sensor, then you have light sensors, gas sensors, you have potentiometers, all of which produce variable voltage outputs based on the environmental conditions. And here the waveform, it represents an analog signal that changes continuously with time, and this ADC block demonstrates its conversion into digital values for processing by the Arduino. Now for comparison here, we are summarizing here the digital pins also, that is from 0 to 13, including the RX pin, that is 0 pin, and the transmitter pin, that is the 1 pin for serial communication, and also the PWM pins from that is 3, 5, 6, 9, 10 and 11 for generating the variable output signals, and pin 13, it is connected to the onboard LED. So here this is about the analog pins A0 to A5. Next comes the power pins. So here we'll see the power pins and also their functions in supplying the power to the board and connected electronic components. These pins allow the Arduino to operate using an external that is a power source or regulated output voltages. Okay, here you can see the power pins. These all are the power pins. Now here these are highlighted. Okay, and here these include what? These include the IOREF, reset, 3.3 volt, 5 volt, ground, then and the V-in. Okay, so these all are the power pins. Now you have V-in, that is this pin, it is used to supply the external power to the Arduino from a battery or a DC adapter, and a voltage between 7 volt to 12 volt is recommended for proper operation. So here you have a 5 volt pin which provides a regulated 5 volt output which can be used to power the sensors, modules and other external circuits. Similarly, we have 3.3 volt pin which acts as the common reference point of the circuit and complete the electrical path, ensuring proper current flow. Then you have the reset pin which restarts the microcontroller and reruns the uploaded program, which is useful for these are useful during the testing and the troubleshooting. Then you have the IOREF pin which provides the operating reference voltage of the board, allowing compatible shields to automatically detect the correct logic voltage. So here you have the ground pin which completes the electrical circuit. Okay, so here from this image you can have a clear overview of the Arduino UNO power pins, their locations and their importance in powering the board and interfacing with external electronic components. Next we have the AREF pin. AREF is nothing but the analog reference pin of the Arduino UNO, and its role in improving the accuracy of analog measurements can be seen here. So the AREF pin, it is located near the ground. Okay, here it is highlighted with yellow now. So this is the AREF pin, and it is used to provide an external reference voltage for the Arduino's analog to digital converter, that is the ADC. Okay, and by default the Arduino UNO, it uses 5 volt as the reference voltage or 3.3 volt on some boards. Okay, here. Now, but the AREF pin, it allows users to supply a custom reference voltage when greater measurement precision is required. So here you can see how the analog signals from A0 to A5. Okay, here analog input signals from A0 to A5 pins, these are converted to the digital values ranging from 0 to 1023 by using the 10-bit analog to digital converter, that is the ADC, and the external reference voltage it is connected to the AREF. Okay, here this is the external reference voltage which is connected to the AREF pin. It becomes the VREF. Okay, it becomes VREF which is used during this conversion, resulting in more accurate readings, especially for low voltage sensors. Okay, this here. Now here you can also see where you have a, see here, this is the AREF Now it becomes the VREF, that is the reference voltage, okay, which is supplied via the AREF pin. Now here you can see you have a circuit where you have an external voltage of 2.048 volt, that is the reference source. It is connected to the AREF pin. Okay, this is connected to the AREF pin. Now to use this feature, here you have a Arduino program which must include the statement analog reference in bracket external. Okay, now applications of the AREF are like it includes a precision analog sensors, battery voltage monitoring, then it has low voltage sensors and high accuracy ADC measurements. Then next you have ICSP pins. ICSP is in-circuit serial programming. In-circuit serial programming pins of the Arduino UNO. And here the ICSP header, it is a 6-pin. Here you can see it is highlighted here. It is a 6-pin. Okay, 6-pin connector located on the Arduino UNO board. It allows the ATmega 328P microcontroller to be programmed directly without using the USB interface or bootloader. Now this method is commonly used for burning a new bootloader and restoring corrupted firmware or programming a blank microcontroller. Then here this image, okay, it shows 6 ICSP pins, that is the MISO, which is master in slave out. Then you have VCC, then you have SCK, that is a serial clock. You have MOSI, master out slave in. You have reset and ground. This MISO, it transfers the data from the Arduino to the programmer, while MOSI, okay, here you have MOSI. This MOSI, here you can see the you have the pin description of all the 6 pins. MOSI transfers the data from the programmer to the Arduino. Then SCK here, it provides a clock signal that synchronizes the data transfer. Then you have VCC, which supplies the 5-volt power to the target board. Then you have ground, which provides the ground connection, and reset, which places the microcontroller into the programming mode. Now besides the programming, ICSP header, it is also used for SPI, that is the serial peripheral interface. Okay, so communication which enables high speed data exchange with devices such as the SD card, then modules. You have SD card modules, you have displays, sensors and Ethernet modules. So here you can see how a programmer or another Arduino board connects to the ICSP. Okay, here in this diagram, ICSP header using an ICSP cable. So this is the cable which is used for the connection. So here you can understand a clear picture of the ICSP pins, their functions and their role in the programming and SPI based communication on the Arduino UNO. Then next you have USB port. So here the Arduino UNO, it uses a USB type B connector, which serves as the primary interface for programming, communication and power supply. Now when the board is connected to the computer using a cable, okay, it establishes a reliable connection between the Arduino and the Arduino IDE. Now one of the main functions of the USB port is uploading the programs, that is the sketches. In Arduino, we call programs as sketches from the Arduino IDE to the ATmega 328P microcontroller. Now the USB connection, it is also used for serial communication with the computer, allowing the Arduino to send and receive data with the computer. And this feature, it is useful for monitoring sensor values, debugging programs through the serial monitor and exchanging data with external applications. And here it also provides a regulated power supply, enabling the Arduino UNO to operate without an external adapter while it is connected to the computer. And internally the board, it uses the ATmega 16U2, the USB to serial converter, to convert USB signals into serial communication for the microcontroller. So here If both the USB cable and the external power supply are connected, the Arduino automatically selects the appropriate power source here. Okay, you can see it, appropriate power source, and using a good quality USB cable, it ensures stable communication, reliable programming, and uninterrupted power, making the USB port an essential interface for developing and testing the Arduino projects. So next is the DC power jack. So DC power jack, it is used to power the board using an external DC adapter or a battery, and it accepts a standard 2.1 millimeter center positive barrel, which is connected like barrel connector, where the center pin is positive and the outer sleeve is negative. Okay, the center pin is positive and the outer pin is negative. Sorry, outer sleeve is negative, and the recommended input voltage is here 7 to 12 volts, which ensures stable operation of the Arduino. And the onboard voltage regulator, it converts the input voltage into a regulated 5 volt, that is supply, which is required by the microcontroller and the other onboard components. And here we can see that the DC power jack, it can be connected to either an external adapter or it can be connected to a battery, making the Arduino suitable for portable and standalone applications. It highlights that supplying less than 7 volt may cause unstable operations, while the voltage is above 12 volt may overheat or damage the regulator. Okay, so it should not exceed about 12 volt to avoid the damaging of the board. And here the DC power jack, it provides a safe and reliable method of powering the Arduino UNO when a USB connection is unavailable, making it ideal for embedded systems and field applications. Then comes the microcontroller. Here it is the main processing unit of the board. So the Arduino UNO, it uses the Atmega, that is a 328P microcontroller, which is often called the brain of the Arduino because it executes the uploaded programs. Okay, and also it controls all the board operations. Now it receives an input signal from the sensors. Okay, it receives the all the signals from the sensors, switches and other devices. Then it processes the data according to the programmed instructions and sends the output signals to the components such as the LEDs, motors, displays and the buzzers. And the microcontroller also supports communication through the interfaces such as the UART, SPI and I2C. And it allows it to interact with other electronic devices. Now here there are some key features of the Atmega 328. So here the features are it is a 8-bit AVR RISC architecture. Then it has a flash memory of 32 KB, then SRAM of 2 KB, EEPROM of 1 KB, operating voltage is 1.0 volt to 5.5 volt, and the operating frequency is up to 6 megahertz. So here you can see the pin configuration of the Atmega 328P. So this Atmega 328P, it is responsible for executing the programs, processing the data and controlling all Arduino UNO functions. So this is about the Arduino UNO pin configuration. I hope you all have enjoyed the video. Thank you.